All right. Well, thanks, Brian, for your time. What we'd like to do is just give you a presentation of where we're at right now with our research study. This is our first run through. We just finished the slides. What we'd really like is your feedback and to see if there's a different way that we should be looking at this data,
right.
And just your general feedback on how the project went along.
Sure.
So I'll start, and then the students will each take a slide, and I'm just pointing at them, so they'll be ready when that time comes.
Right.
So the title really is Soil Moisture from Within and Above Bowling Green State University, and I'm going to have the group introduce themselves. So we'll start with Bonnie.
Hi, my name is Bonnie Altstetter.
I'm Logan Bretz.
I'm Kim Wheatley. I'm Janelle Mangin. I'm Beth Zena. And I'm Emma Constance.
All right. And
Hi, everybody. Thank you so much for all the awesome work you guys are doing.
Yeah, no problem.
it's been fun. It's been a lot of fun. In case you see some slides that say CIA, that's our kind of our handle, our team name. And this group came up with it, and they really thought it was really great that CIA was working with NASA.
Yeah.
The rumor mill might, not be so good there, but and CIA stands for what, Bonnie? I think that was your invention.
Contagious intelligent adults.
Yeah, contagiously intelligent adults. There we go.
It's been a while since we
So
started.
I like it.
CIA. All right, so we'll start with our research questions.
Okay, we had 3 research questions throughout our project, and the first one was, how did soil moisture differ across the 9 testing sites? The second one was, how did the GLOBE program SMAP bucket soil drying method data compare to the GLOBE oven drying method data? And our last question was, how did our data compare to the NASA SMAP data?
Okay.
And then we have, why is investigating soil moisture important? And in the environment, soil moisture influences multiple parts of the atmosphere. By understanding soil moisture in I can't say that word. Specific. Nope. It allows predictions for flooding, droughts, weather forecasts, carbon cycles, and crop productivity. Soil moisture is different everywhere. Therefore, it is important to understand that these variations can result in different circumstances, such as flooding and droughts. The NASA SMAP satellite measures globe soil moisture from the top 2 inches of soil from space, and GLOBE schools measure this in the soil from the ground.
Okay.
So here are materials.
And just for the sake of this, we're going to skip through this because I think you know the materials, Brian, unless you want to hear more about those.
Sounds good.
We can't hear him.
Sorry, I put myself on mute, so I wasn't interfering.
Okay.
Yeah, you can continue. That's great.
Okay, so you're going to do the next slide.
Okay, so here are our methods. First, we dug out the surface area of grass from the preset grid on the site, and then we placed the aluminum can open side down into the ground, and then tapped with a hammer until the soil filled the can and showed through the hole. Then we scoped out the can using a shovel, keeping as much dirt as possible. Then we wrapped the filled with dirt and plastic wrap and placed it in the plastic bag. Took the soil samples back to the lab and weighed each can. We placed each can in its respective 75 degrees Celsius bucket or soil oven. Then the following week after the soil was dry, we took the dry weight of the soil. We measured that. And then using the same can, we took the volume of the can, calculated the percent moisture, and reported the data to both the GLOBE website and the Google Sheet, and then repeated steps 1 through 9 for all 9 samples in all the cans.
Okay, so for results, let's make sure we're reporting out on the results that you collected. So this one's right? Worked out well. Okay, Kim.
Okay, so for our first question, we asked how did soil moisture differ across the 9 testing sites? And then this is the graph that we received. We, I want to say, categorized every site into irrigated land, non-irrigated land, and then natural, and then placed them in the order that we thought would have the most soil moisture. And we discovered that they're pretty much all the same, except for the irrigated land tends to have more soil moisture than the non-irrigated and the natural.
Is that an average?
Yeah. Yes.
Okay.
Okay. So that's for all 8 weeks, right? Or 8-week averages.
those are all the-
Cool.
This one's so good.
All right, so what our research question that we did, we were comparing the bucket method to the oven method, and what we came to find with the 3 different sites here, the Tech Pond, Golf Course, and Library, that the bucket method and the oven method are very, very similar, if not pretty much the same. So those are, again, averages.
And you want to, we actually ran a t-test on that, and you found that statistically, the p-value, yeah, you remember it was statistically non-significant.
Yeah.
Oh, yeah, that is right. Okay.
Okay, so we should probably add that to that graph.
Okay.
Okay?
Sounds good. You guys.
So for our research question, we were looking for comparisons between our data and the SMAP data. And so here's a graph of that. And we found that there was, for the most part, they were fairly similar, but there was a couple of days where they were very far apart. As you can see, like November 30th was very far apart. There might be a couple of reasons for this. One of the reasons is that NASA, the website, didn't always catch the same area on the same day as us. So sometimes we had to use NASA's website. We had to go to like the next day or the day before to collect the data. And then there was a couple of days that we had to throw out as well.
Because there was no SMAP data.
Mm-hmm.
And then
2 days, yeah.
what we did is that we screenshotted on the Globe website and then put a little dot around where we were at and then put down the scales. And it was kind of difficult to get an exact number because, again, it was like 0.15 to 0.2. So, and sometimes they were in between colors. They weren't exactly that dark green or that light of green. So it was kind of difficult to do that. But we did the best we could to make sure we could get the best measurement we could.
Yeah, that's completely understandable. You know, because with just the radiometer working on the satellite, the resolution is about 36 kilometers. So if the radar was still on the working on the satellite, that would be a lot finer, and you'd be able to go a little, further into the map and look at a more differentiation of color. But as you may know, that we're actually working with a European satellite that flies behind the SMAP satellite in orbit, called Sentinel, and it also actually has a C-band radar on it. SMAP has an L-band radar, which is the one that's no longer working. The C-band radar just takes it under a different frequency, but it would give us back to that, what we hope for under, between 7 and 8, maybe even lower than that kilometer resolution. So a little better. But yeah, that's completely understandable. And that it's kind of hard. It looks like, because looking right in the middle of that circle, I don't know if it's my eyes but it's green and there's a little orange in the middle as well.
Yeah,
So
the orange is the dot of where we're at, and
okay.
where is the color that we're supposed to be in.
Cool.
Because it was trying to label it for us, but it was such a light color that we just went in and put a black circle around it to say that's where we're at.
Yeah.
And then to the side on the right on our PowerPoint, we kind of compared what Globe measured and then what we measured. Oh, we forgot to put a decimal point there.
Yeah.
But it was, and we only did this for 4 days where they lined up exactly on the days we took the measurements.
With globes. But with NASA's website, we were actually able to get more than just the 4 measurements that Globe had. It was a little bit harder to do with NASA's website because we had to...
The world view?
Yeah, we would have to screenshot like the color and then try and match it to the scale by screenshotting them and comparing them. So it probably wasn't the most accurate way to collect data, but that was the best that we could come up with.
Mm-hmm.
We've been telling our colleagues who run that worldview that there's a lot of user, ease of use issues with it. It's not as efficient as it should be. So we're actually looking into that.
Awesome. Then for our next day, again, they're pretty. Oh, is there something going on?
Yeah, it's not letting me go to the next slide. Whoops.
Oh,
Let's try that again. Okay, there we go.
So the next day, they're again pretty close, like 0.3 off from or 0.03 off from each other. And then the following day, this one's a little more far apart than what we like to, but again, had to do with oh no, that was something different. Our averages may have been higher that day because we may have gotten rain or there was frost on the ground in our areas than maybe other areas. Yeah. And
So
then,
probably what we should do, I'm just going to speak out loud, is that you guys have some information about what was happening on these days that the
Yes.
audience won't see. So you should probably add a little box of metadata so that when you're up presenting, you can say, on this day, this is what, because you collected metadata.
Yeah.
Let's talk about the metadata that you were collecting to say, is there anything there that might explain some of these differences that you're noticing?
Okay. And then I believe the fourth day we recorded, I think that was the furthest one off. We collected like 0.26, and then Globe said it was about 0.1. So that was, I guess, our outlier that we have for ours. And then conclusions.
Okay. So for question 1, how did the soil moisture vary across the 9 sites? Based on our data and graph from the 9 sample sites, we concluded that irrigated land has the most soil moisture and natural land has the least soil moisture. So overall, however, there's not much variance between each of the 9 sites' soil moisture. So just comparing them overall.
Okay.
All right, for the second research question, this is with the oven and the bucket method. We found that there is no large variation between these two. Therefore, if a school did not, like if they were conducting this research, and they did not have the resources to use an oven, they could use the bucket method and it would be just as efficient.
For our final research question, we said the data that we collected ourselves was on average 0.04 milliliters per milliliter higher than the SMAP data that was collected. Data comparison varied between our data and SMAP's data depending on the day and site. Some days were very close in comparison, while others were completely different.
Yeah, that's it, right?
Trying to adjust my light here. I'm in a weird shaded area.
Okay. No, there's one more slide, I
One
think.
more slide.
I'm sorry.
And I guess our next steps, if this research would be continued, we could take data samples of soil in different areas and regions, just besides Bowling Green. We would also recommend that you pay very close attention to what days and times the SMAP satellite will be collecting data in that region that you're collecting data from for comparison. Perhaps collecting data in different environments such as deserts or tropical regions and tundras would be interesting for comparisons as well.
We're working.
I'll go with you to the tropical regions.
Yeah, I'll volunteer for that too. Okay, and this is some of the references, research that we used. And this is our first run through. The students were working in Google Slides, creating this last Thursday as I was driving home from Nashville for the NAR meeting. So this is their first run through. I think they've done a fairly good job. We'd like to have your feedback on some things that we could do to improve this, because we'll be presenting it to the Ohio Board of Regents, who funds this grant project that that they're involved with, and then maybe at a Globe meeting in the future.
Yeah, definitely.
Yeah.
Yeah, I mean, it was excellent. Can you go back to the slide that compared the bucket method to the regular method?
Sure.
So tell me a little bit, how did you, within the block pattern setup, how did you collect the oven versus bucket in the same site on the?
Yep. You guys remember how we did that?
We did it just right next to
Yeah.
each other on the
Okay.
same side, so they're probably a couple inches away from each other
Okay.
in the oven and the bucket for the same amount of time at roughly the same temperature. Yeah.
So we marked our sites with we actually used spray paint, so that after we finished a site, we sprayed it so we know to move to the next spot on the next week. And then oven, just because we were running out of room in the buckets, so we had 9 sites, but only 3 sites, Tech Pond, Golf Course, and Library, did we collect both an oven and a bucket sample.
Okay, yeah.
So it's still 8 weeks worth of data, but only in 3 sites.
Okay, and go to the next slide, please.
Yep.
So one, I guess, thing to, the colors on the previous slide match this slide, and I don't know if they should.
Okay.
Only because when I first looked at this and I thought, oh, before I even looked at anything, I said, oh, they're comparing the oven versus the bucket method again.
Okay. That's a good point.
Yeah, I noticed it, but then I looked, I was like, no, and then started a discussion, and yeah, it was all about the averages. Yeah, this is really, because I think probably this is the most important slide that's in your entire presentation, because this actually gets to what we want and what we hope for by bringing the satellite validation into the mix.
And I thought that, yeah, I agree. And I think the titles too, the feedback that I was looking at last week is that they didn't have a chance to even hear this from me yet, is that some of the titles of these graphs can be a little bit more detailed so that we know exactly what we're looking at. Even though the research question is up above, but just the title of the graph will help.
Yeah, I mean, this could be something, this could be something, our, globe collected data and how it can be used to, how this data compares to the SMAP satellite data to use in validation. So, or something like that, I'm not a wordsmith today. My brain's a little mushy right now, but yeah, I think this is definitely the most important slide in here. And you really want to, who you present this to, this is what you really want to focus on. And I know Erica, if she was on, she'd think the same thing, because she and her colleague Narendra at Jet Propulsion Laboratory, they're SMAP scientists. They really look at this data. Narendra is in the process of extracting data from National Snow and Ice Data Center, the SMAP data, and then he's going to be, sending it to Erica to compare to different sites across the world that have collected this data. But this is a very powerful slide right here, because it really shows. It shows one thing that if the measurements match up pretty much in some points, plus or minus a couple hundredths, but then you have, of course, an outlier in the group, and that's a great way to explain. It could be, is it a technical error? Is it a user error? Is procedural error? That's all. This slide can be used for lots of discussion.
Yeah,
for sure.
And then, Brian, the conversation was taking place, again, my students haven't heard this yet, but Jackie Kane is a high school teacher in the area who is really outstanding. She has her students doing research all the time at an all-girls high school. And she started thinking about SMAP, and that's the conversations we were having this last week. And she was worried about the differences between the globe data and the SMAP data, saying that there's some differences there. But one of the things that Erica said is that, you really should be looking at, or maybe it was you, Brian, but somebody said you should be looking at trends.
Yeah,
so
yeah.
I'm wondering if we shouldn't also have a line graph, even though I told the students that we should have a bar graph. I'm thinking maybe a line graph might be helpful here as well, to look at how the trends, to look at the trend.
Yeah, let me share my screen and I'll show you. We did a line graph between some of the globe data and some of the one of the Croatian schools, and I'll just show you how, this is very important, this graph for sure, but yeah, maybe a line graph. So I'm going to share my screen real fast and try to grab it. Oop.
Keep turning. Different people. Different people.
I have to try to, oh, I know what I have to do here. All right. Sorry, I've had to close a couple things here before I.
No problem.
There's too much on my screen. All right.
You know what I mean? Maybe putting a line over that too, the two colors.
I think you can. It's like a dashed line
Yeah.
you can do on top of both of those. Because we see the trend, our data is always a little higher than the SMAP data. Because I think that's what our previous
Always.
line graph showed too. Like there was like a space
Yes.
in between. Yeah.
So, and that shows
That's
that the trends are the same, right? That something's working right, because we're consistently higher than
Yeah.
SMAP by a little bit. But this one's the one that's really interesting to talk about.
We'll have to double check on
Okay.
data on that.
I don't see that one. Okay.
You see that on there?
Yep.
All right. So yeah, you can really see the globe data, which is the black data. This is a school that this is a school. They're overachievers for sure. They started collecting data way back in April, and way before the campaign actually started. But you can see here the line for this is their measurements, and then this is the actual satellite measures. You can see in the beginning. We're attributing this to a little bit between user error, and also in Croatia around this time, the soil was still frozen. So there's a little bit of difference here before we actually got things straight. But you can see here, once you hit about, mid-June, you can see how it, even though it is a little higher, you can see the trends. You notice those? And that's exactly something that you can create with that, with your your graph that you created, something like that, that would really show this kind of overlaying. And you, by what you see, other than, this all the way at the end, you're going to see a huge difference between the two on your graph, but you will see trends just like this. And that's such an important thing, because even though the measurement is off a little bit, you have this nice wide open space here, but even though it's off a little bit, what you're looking for are the trends. And when you see those trends, something's going right.
And interesting, this is just two schools, but it's interesting that both this school in Croatia and our school, our globe measurements were higher than the SMAP measurements.
Yeah.
So that's interesting,
Yeah, and that might be something that we can discuss with Erica Narendra and say, hey, why is this? And maybe if some other schools are coming, because I know Kevin Chakowski is doing some as well.
Right.
So I haven't seen his data yet for this, but it'd be nice to see that and see if there is a trend.
Yep, absolutely. Great. That's very helpful. I have access to this graph. I saved that email, so I have that graph. We might even put that in and say, and here's another school that was collecting data and
so that it's
compare
similar with ours.
Similar.
Yeah, that'd be a good idea. That'd be a real cool idea. Yeah.
Yep.
And then definitely you could share it with Marina from that Croatian school. Marina Barasic is the teacher there.
Great.
And I'll forward you her email, Jody.
That would be great.
Yeah, just so you can have that. Because I think that'd be really cool.
Great.
Yeah.
Okay.
All right. Can you go back to your, maybe share your screen again?
Yeah.
Might be a couple things might look at. But yeah, definitely that slide that slide right here is the backbone of all the slides on here.
Okay.
They really want to feature this, prominently.
Okay.
I think it's at a good spot in the presentation.
Okay. And then I something that I noticed just while we're all getting feedback here, so remember this, because after we're done here, you guys can make some of these corrections. But for the bucket method, that's not there yet.
It was before that.
Okay, yeah, bucket. So, whoops, actually it's in the conclusions. We say that the bucket method is just as efficient, and really, I think we mean effective. It's a small difference, but we're really saying that we didn't get any difference in data, so that it's a valid way to go about it, that you're going to get the same results using the bucket method or the oven method. Because efficiency, it's actually less efficient. We had to dry the soil over a week, Brian, because what we were noticing is in the bucket, if we only went 2 days,
Yeah.
you have to get either the bucket so low or the light so low to the bucket that it melted. That was a problem. So then when we lifted it up a little bit, 2 days wasn't quite long enough. So, and we could only get it to 75 degrees. So we turned our oven down to 75 degrees to make sure we were matching those two. And then we tried 3 days and then 4 days. And then what we realized is, well, we met with these students only once a week. We said, let's just go a week and then we know it's dry.
Yeah.
We did do the 4 day and the 7 day and got no differences between those. So we just decided to use a weekly method. But that, I think, something that for other schools around the world that are going to use the bucket method, this will be an important point as well.
Yeah, for sure. I wonder if there's a way that you can manipulate the bucket a little bit. I have to think about that now that I know that that's kind of the issue. Maybe some way to vent the bucket without actually losing any of the soil. But
yeah, and or a metal bucket. I know metal buckets would probably be better because you could get that light down in there a little bit better too. And just for your information, because I thought this was so fun, this summer when I was getting ready for this group, I actually created a solar bucket. I took a black bucket with a lid and I vented it at the top. I just drilled holes around the top just so that some air could get out of there.
yeah,
I could get the solar bucket to 75 degrees, no problem, in northwestern Ohio.
wow.
So I'm thinking for some of the schools that really don't even have a heat lamp that are sitting on the equator, and I even left it out like in the rain to see if I was going to pick up moisture. It was totally fine. I mean, if I left it out there long enough, I was able to dry it and keep it dry.
Yeah, wow. Yeah, that's pretty cool.
Yeah, so that might be something just for, I don't know, for the discussion for another day.
Or perhaps that could be a discussion on one of our webinars coming up.
Yeah, that'd be
If you'd be interested in, maybe, you or your students showing, a couple of these slides, I think everybody in the community would love to see it.
great. We'll be ready very soon here. We just want to.
Yeah. Well, it won't be until I believe the next one is May 3rd, whatever that Tuesday is, May 2nd, 3rd, something like that.
Okay, that's her exam week, I think.
Yeah.
But that's okay. It's in the evening. Need a break. They're short webinars.
Yeah, because the SMAP ones, you know, I'm actually going through Globe now because the original campaign, the SMAP campaign, was to run till April 30th.
Yes.
We want to extend it till the end of the year at least, so I'm having to go through Globe and do an extension form for that.
Okay.
So, yeah, so
Great.
we'll be doing that until hopefully by the end of the year upon approval. I hope it's just a formality that I'm actually filling out
You mean
these.
through December then? Go all the way through December.
The summer will be a little iffy because, you know, we have schools in the southern hemisphere that are still going to school, but the majority of the ones collecting the soil samples are from northern hemisphere. And there's not a lot of school they're actually collecting at that time.
Yeah. Okay. We might be able to pull that off though. I've got some ideas there on
Well,
that.
we'll be in contact and
Okay.
definitely figure all that out.
Okay. Great. Any other comments for us or any other questions from the group?
I'm sorry.
Yeah, I think it's an awesome job. You guys did a great job, and I love, you know, how you spread it out throughout campus and it wasn't in one concentrated area. Yeah.
All right. Well, thank you very much, Brian. We appreciate this.
All right. Thank you guys so much.
We'll be in
And,
touch.
and once the recording gets processed, it gets processed through Zoom. Then I will, you know, send you the link to it. I'll probably put on YouTube and send you the YouTube link so you can check it out.
That's great.
All righty.
All right. We appreciate it very much.
All right. Thanks. Have a great one.
Bye-bye.
Bye.